Good morning, everybody, and welcome back to Next Door NET Admin. One of the things that I am often asked for as a network administrator is to make a port forward work from inside the network. People will say, oh, we've got a domain name set up that points to the external IP address, and the port forward works from outside the network. Can't we just make it work from inside the network as well? I mean, at first glance, you would think that it absolutely should work, because from inside the network, if you're going to your external IP, well, it should go to the router and it should see that it's going to the external IP and it should just port forward it right back into the network again. So what's the problem? The problem comes when you start to think about what's actually happening at the network level. So let's dive into this. You have to consider the fact that network address translation, or NAT, is what's in play. And it's only in play in certain circumstances. I usually think of this as the network having an order of operations. If you've done math to any extent, you'll know that there's an order of operations. You're supposed to do your exponents first, you're supposed to do your multiplication and division, and then you get to the addition and subtraction. If you see a whole bunch of these without parentheses to tell you exactly what to do first, then that's the order in which you're supposed to do it. If you see 5 times 6 plus 2, it's not 6 plus 2 times 5. It's 5 times 6 plus 2. So the order of operations matters. And on the network level, network address translation, typically speaking, is on your external interface. When a packet comes into the network, you'll do network address translation first to say, oh, okay, so this is going from this external. If you're coming in and you're bound for this external IP address on this port, then I'm supposed to translate that to a destination of this internal IP address and this port. Okay. Then you get to your firewall, where it checks, is this translated traffic permitted from this interface? If you've done zone-based firewalling in Cisco iOS or your rules in OpenSense, you'll know this is exactly how it works. If you set up a rule or a firewall rule, you don't filter based on the destination of the external IP address. You filter based on the destination of the internal IP address, because it's doing these rules after it's done address translation. And then once it's done the address translation and it's been verified that it's permitted through the firewall, then you'll get to the routing table, and the routing table actually tells the router which interface is this traffic supposed to go out of, and then it will route it. The way I think about this is, okay, so if it's coming into the router from the inside network, and it's got a destination of the router's external IP address, it hasn't gone through NAT yet, and it doesn't have to go through the firewall, it's coming in on the inside. So it gets to the routing engine, and the routing engine says, oh, it's bound for this external IP. Oh, hey, that's right here. It's already at the destination. Done. End of story. There's never an opportunity for it to go through the network translation to actually hit the port forward before it goes back into the network. That's how I usually think about it. And people go, well, I hear there's this thing called NAT hairpinning or NAT reflection or NAT loopback. There's a few different names it goes by. Why don't we just enable that? No. No, we don't want to do that. Why not? Well, because that complicates things a lot. It really, really complicates things. It's made a little more complicated by the fact that a lot of consumer routers, consumer gateway devices will have NAT Loopback or NAT hairpin kind of just built in by default. So people who have networking experience mainly from the home will just expect that this is a thing that it does. Particularly if you're using gear that's based for the home, this is commonly built in. If you're using anything that's built for actual business use, actual enterprise use, it doesn't do this by default. And if it has the option, it usually comes with warnings. OpenSense, for example, has an option that you can select to enable NAT hairpin. And they highly recommend against using it. So much so that currently their how-to for this says, don't use this feature. The feature that was just a checkbox to enable this is going away because it created just as many problems as it tried to fix. So they have a different way of setting it up now. And looking at that is instructive to give you an idea of what kind of manipulation you have to do on the traffic in order to make this work. So let's go back to thinking about how this is supposed to be set up. If your internal station will say 192.168.1.100, just for the sake of argument, is trying to talk to your server at 192.168.1.2. Okay? We're going from .100 to .2. But it's going to the external IP address. So your workstation is going to say, well, this is going to a public IP address. I need to send this to my default gateway. So it'll send it to the router instead. The router will get it and say, okay, so this is headed to a destination of the external IP address. Now let's say you've got some destination NAT happening there. And it says, okay, well, I'm going to port forward this to 1.2. All right. So it goes to 1.2. Problem solved, right? No. 1.2 gets it, and it needs to answer back. And it looks at it, and it goes, okay, so this is coming from an IP address of 1.100. Oh, that's local. Well, I'm just going to send it locally then, because that's what it's supposed to do. Your workstation, from the workstation's perspective, you started a connection to an external IP address, and then some other station on the internal network started talking to you. And your workstation is going to close the door and say, I didn't ask for any traffic from you. I'm trying to talk to this external IP address. So it'll break, the connection won't complete. And if you have a firewall in there, that definitely won't complete because the return traffic does not match the outgoing connection. It turns out what you need to do if you want to do NAT hairpinning is you need to set up two different kinds of NAT. You have the usual destination NAT, but you also need source NAT. Source network address translation. When it hits the router from 1.100 and it goes to the router, okay, you need to set up a rule that says translate this external IP address destination to a destination of 1.2. But you also have to translate the source and translate it from 1.100 to the external IP address of the router or the internal IP address of the router. I'm pretty sure you translate it to the external address of the router, but whatever you do, you have to make sure that the traffic goes back to the router, because the router is going to act kind of as a proxy in this case. So then it'll go to the server at 1.2. Server at 1.2 sees that the response needs to go back to the router, so that it goes back to the router, and then it has to do it in reverse. Now the destination is 1.100. So it needs to look up its list of translations and says, oh, okay, so there was a session opened from 1.100 to 1.2. So now I need to do the reverse. The destination of the internal IP address or the external IP address has to be translated back to 1.100. And the source of 1.2 has to be translated back to the original destination of the external IP address. And then it sends it back. This is a lot of work. A lot of work from the network's perspective. And as it happens, it has a tendency to really affect the performance of your router. Because not only are you having to do this both destination network address translation and source network address translation, you have to do this on every packet that's going back and forth between the workstation and the server. And if you have multiple workstations going to that server, that's even more effort that you have to do. Network address translation is typically something done by the device's CPU, because it's not something that happens efficiently in hardware the same way that routing or switching can be done efficiently in hardware. So this is occupying a lot of your router's CPU time that it would usually be using for other things like routing, like an administration interface, like any of the other, security stuff that it needs to be doing. It's taking up CPU time, and it's not a good state to be in. Plus, for enterprise level equipment, it's the admin who has to configure all of this. In the case of OpenSense, for example, their current recommended method for doing NAT hairpin essentially says the admin has to manually create the destination NAT rules and manually create the source network address translation rules, and then the firewall rules will take care of themselves. Okay, so it's up to me as the network admin to configure all of this in order to have a potentially large performance penalty on this equipment, just so that you can use a destination IP of the external IP address. This doesn't make a lot of sense to an enterprise network admin. So how do you avoid this? Well, most of the time when this is happening, it's happening because you're using a domain name that is hosted externally, and you're just resolving it externally so that it gives you an external IP address. So you're trying to do that. In an enterprise network, the correct thing to do is to have that DNS zone hosted locally, internal to the network, so that when you query that domain name internally, it gives you the local IP address instead. Then you just go directly to the local server. You don't have to go through the router, and there's no need for NAT hairpin. It should not be necessary at all if you're doing it correctly. This is also why Microsoft's best practices for things like Active Directory is to set up your Active Directory using your external domain name, because this is what you're supposed to be doing. You're supposed to have it hosted internally so that your servers and everything else all have internal IP addresses that your internal domain workstations can then resolve and go to directly. or even over a VPN if you have multiple sites. You're not supposed to set it up with just a random .internal or .local domain name, even though that was common practice for years and years and years. It was never suggested by Microsoft. It was never recommended by Microsoft, because this is exactly the kind of thing that they were trying to handle correctly in the network. If you're a very small business and you never had a server locally, okay, well, maybe this was never an issue that you ran into. But every single place where you have a server internally, you either have to set up a duplicate zone for your external domain name and populate it and then keep that up to date, or you're going to need to fiddle around with NAT hairpin, and that is just so gross from an enterprise network admin perspective. 100 times out of 100, you'd rather be doing it with a split view or split horizon DNS setup. Guaranteed. But there's other instances where a network order of operations can come into play. And a lot of the times it's something that I have, kind of noodled through my head to try and figure out why is my traffic behaving like this? What sequence of steps did it have to go to end up like this? And I'll tell you, the order of operations is not necessarily the same on the way out as it is on the way in. So don't think of this as a fixed sequence of steps such that, when you're going out, okay, let's say you're sending traffic out. Well, it'll hit the routing engine first, then it'll go through the firewall, then it'll go through network address translation. That may or may not be how it happens on the way out. And in fact, if you're doing destination and source NAT, then there's a definite order to that as well. And the order in which it processes these steps might affect how it comes out or what errors you might get along the way. So while I would encourage you to think about the order in which the traffic gets processed, just be aware that it may not be a mirror image of each other from inbound to outbound. They may be different, and you may, and probably should, do a little bit of experimentation and thinking to figure out how that works in your specific environment. But that's all I wanted to talk about today, NAT hairpinning, why I hate it, and why everybody thinks it's so easy, and when you look at it, it's really not. If you have other things that you would like to hear me talk about or questions that you would like to ask, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.